Assalamu alaikum. Welcome to lecture 2 of natural language processing. So in the last lecture, we had discussed the modalities of the course. We also introduced NLP by discussing some applications. We also briefly talked about why NLP is hard. So today, we will continue with that discussion, wrapping up the introduction to NLP. And after that, I will basically introduce some terms and terminologies from linguistics. So these terminologies may be used throughout this course, and it's always good to review them, refresh our mind regarding some of these terminologies from linguistics. So we will discuss those. And towards the end of today, we will also start text processing. So basic text processing. So that's the agenda for today. So are there any questions before I get started? All right. Okay, so let me give another perspective of NLP. This is from AI. So basically, NLP is part of AI. And in AI, we often talk about agents. And agents are entities that exhibit intelligence. So if you think of NLP as agents or NLP processing as agents, you have basically two agents. We have a transmitter and then you have a receiver. And depending on the context, the transmitter and receiver may be different things. So for example, both of them can be humans. So someone is speaking and someone is listening. So again, similarly, both of them can be computer. So the computer is generating something and the other agent is also a computer that's listening to it and acting on what has been sent to it. And similarly, computers kind of include everything, but you can also say you have robots on both sides. Or sometimes you may have human on one side and let's say a computer on the other side. So for example, if you are talking about a conversational agent or chatbot, let's say if you're using a Google Assistant, so human is talking and the Google Assistant on your phone or a standalone device is listening to it and responding to it. So, so both of these are agents. One agent, the role is transmitter. The other agent's role is as a receiver. And just to further kind of characterize what is happening at the transmitter and what is happening at the receiver. So if I talk about the transmitter, so what actions typically occur at a transmitter? So first of all, you have an intention. Of course, all of this is qualitative discussion. We're not talking about in terms of numbers here. So before someone actually generates language, you need to have some intention. What do you want to say? What is what needs to be communicated? So that's the intention. And after the intention, you need to translate that intention into a language. And of course, you need to have a language. Let's say you're talking in English or let's say you're talking in Urdu. So you need to translate that intention into language. So basically, here I would say uh, language composition, for example. So you compose your intention in a language, of course, following the rules of that language. So once you have done that, then you basically uh, encode it into the proper representation that is needed for transmission. So encoding comes next. In encoding, you can have different things. It could be, for example, textual encoding. It could be speech, for example, and so on. And this is the information that is then transmitted over whatever medium you have to the receiver. And then we have the receiver. What happens at the receiver? So receiver, of course, first acquires or mm, reads the received information, the encoded information. So once it has received the encoded information, it basically then it basically understands it. So basically, this encoded information has to be, of course, translated into some form that the computer understands. And once you have understood what is sent to you, then of course you act upon the information. You take an action. So this is, I just wanted to give you a big picture of what happens in NLP, and this big picture can fit into many applications of NLP as we will see throughout this course. So in in almost all cases, you do have some agent that is doing the language generation, and you do have some agent that is doing the understanding and acting upon the information. So sometimes there might be just one agent, the other agent might be, let's say, hidden. For example, let's say you just have data available to you. Let's say lots of, let's say, tweets are already available to you, and then you just want to maybe classify them as, let's say, positive or negative polarity. So that is just the receiver part, trying to understand what you have. We have kind of omitted the part of generation and transmission. But in general, both of these things would be available, and any task that is done at any of these ends is NLP. All right, so any quick question here before I move on? Okay, let me now go back to my slides. So this slide identifies or highlights several applications or tasks in NLP and mentions which one have been solved, which are uh, in which good progress has been made and which is still relatively difficult. So if you look at this slide on the left side, you have problems that are already solved to a very large extent. So you can think of problems like spam detection. Spam detection, of course, is text classification. So text classification and especially spam detection is now fairly well defined, and you have very high accuracies available. So similarly, you have tasks like named entity recognition. So named entity recognition is trying to identify names of people from running text, or trying to find locations that are written in running text, or trying to find other entities. Entities could also be dates, for example. Uh, so that is also relatively solved. POS tagging, POS stands for part of speech. We'll look at this shortly. So noun, verbs. So what are the nouns in a sentence? What are the verbs in a sentence, and adjectives and so on. So this is also relatively solved problem. And of course, we'll be discussing all of this in this course. So what is making good progress? Sentiment analysis, we have fairly good results, but there might be some room for improvement here. So WSD is word sense disambiguation. Basically, you might have words that have different senses, and we will talk about senses as well in more detail in this course, meaning that you have different meanings for the same sequence of characters. The typical example that is often given is the word bank, BANK. So bank could be the financial institution, the building, or the institution, or it could be a river bank or some other thing. So trying to find which meaning is meant in running text is called word sense disambiguation. So this is also fairly well solved now. Uh, but I mean, we don't have, of course, 100% accuracy. And co-reference resolution basically implies that usually we have multiple entities mentioned in discourse in running text. And then you have various pronouns. For example, he, she, and he is mentioned. Let's say if you have two names mentioned in a sentence, and then later on you have he did this. So which name is he referring to? So that is co-reference resolution, trying to find out which reference is made to which entity in running text. Of course, this is to be done by computers. When we read, we typically do this without much effort, but for computers, it is relatively difficult. So what is really hard? Most things that are still really hard, but of course, we have made lots of progress there as well, is language generation related. So question answering, for example, chatbots. In both of these cases, you need language generation and also good language understanding. So we have made lots of progress here as well, but I would say okay, there's still a lot of room for progress. Of course, paraphrasing, meaning that if you have written something and you want to uh, rewrite it to convey the same meaning. So for computer, that is still relatively hard. Generating summaries is also relatively hard. And of course, understanding dialogues or generating dialogues. So all of these are still relatively hard. So any question here? So as we mentioned last time, why is NLP hard? Primarily because things are ambiguous. Language is ambiguous. Even if we say that English has grammar, which is set of rules for writing good English, those those rules are not followed always, and still you will have correct language. For such scenarios, it's difficult for computers to understand uh, everything at all times. So that is the challenge, ambiguity. Ambiguity arises because of the language and because of the users of those language. So users of those language are whom? People. So people write in different ways. You have spelling mistakes, you have grammar variations, you have new words, you have, for example, in English, you have idioms. We do not translate literally, uh, and many other variations. People write in different ways. They have also different styles of writing, for example. So how is this tackled in general in NLP? So any questions? Okay. Okay, let me move, I think, over the slide. So what tools do we need to solve NLP in general? So you need to have a thorough knowledge of the language, and this knowledge cannot be gained from books of grammar, for example. As I said, there might be rules, but those rules are often flaunted or violated in writing. And then also you need knowledge of the world because meaning is often derived from the world around us. And of course, also words are often coined based on what we have around in the world. So both of these information has to be known to the computer. And then, of course, we need to be able to combine knowledge and then process them and make inferences. And how do we generally do this? Usually it's a probabilistic type of framework, sometimes explicit, but nowadays more commonly it is implicit through, let's say, neural networks. But if it is explicit, then so you learn the language from running text, you learn the usage, the world also from usage of words of regarding the world from text, and then you combine them to make inferences. So just to give a quick example here. So for example, I write a sentence like I like pizza with and dash 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 dash. So let's say if you have something like this. So what is the most appropriate word that would come at dash dash dash? So let me give some examples. So chicken and let's say, could it be, let's say, lumps, for example? Could it be, for example, the word is? Could it be, for example, let's say, mushroom? Could it be something, some person's name, let's say my name? So which word is more likely to be present there? And how do we know which word is more likely? Any ideas? So mushroom is the right answer, yes. But why? How would a computer come to this conclusion?
Probability.
So if you think in terms of probability, so there is a context. So I like pizza with chicken, and so the context is all of these words. So the context pretty much uh, specify what is the likely words that would come after that. So let me say probability of Asim, for example, given my whole context. This is, let's say, one probability. Let's say it has some number. And the other probability, let's say, is probability of, let's say, mushrooms, given the context. So which probability would be higher? Of course, you will have to estimate this probability. So the second probability would be higher because if you look at large amounts of text, you are not likely to see the word Asim after a whole discussion of pizza and mushroom, pizzas and chicken and so on, but you are more likely to see the word mushroom. Okay? So we basically thus extract or learn knowledge from running text and then apply that knowledge to make inferences. So almost all of modern day NLP is like this. Okay? Of course, in the start, we have some algorithmic approaches, but those are typically used for uh, string processing and basic stuff. But for more advanced stuff where you have ambiguity, we will have to do learning and we have to do inference. All right. So similarly, you can think of, let's say, if I misspelled some word, let's say I wanted to write something, but I wrote something that is misspelled, maybe missing some characters in it. So the probability of a misspelled would be much less as compared to the correct spelled word if you look at written text that is available out there. So misspelling can also be determined from estimations based on learning. So in recent years, there are a couple of two or three important trends that have arisen in NLP. So you can learn the language from large amounts of text. Simply just look at and learn from large bodies of text, maybe books, magazines, newspapers, whatever that is written in that language. By just processing that information, you can learn a lot about that language. The vocabulary, for example, the rules, should a noun come before a verb, for example, uh, which words are, for example, used as nouns, let's say entities like locations and people's names and so on. So all of this can be derived or learned relatively easily from large amounts of text. Of course, all of this would be probabilistic knowledge. There is no determinism there. So, for example, just like I mentioned last time, or even for the example I gave earlier, bank, BANK, this sequence of characters may mean different things in different contexts. So if you want to think in terms of probability, then of course, depending on the context, one meaning would have some probability. Depending on the context, the other meaning would have another probability. So language modeling is a key component of modern day NLP, and a lot of this course will also focus on that. We look at probabilistic language models and then also neural network language models. So in recent years, there's also a trend towards pre-trained models, and lots of those models are already available to us for many languages. So, and these models are usually trained in the form of neural networks, pre-trained neural networks, or deep neural networks, you can call them. So, and one typical form of neural network is very popular, which is called a transformer. So I've written that there's a transformer race nowadays. So I've written some names here, and we will be discussing some of these architectures later in this course. And the other phenomena is basically feature representation end-to-end learning. And this is also part of deep learning. Uh, in other words, we don't do explicit feature engineering. We let data, we push data through a neural network, uh, and we give it training examples and let the neural network do the feature engineering, feature representation, and get the results. So you have input from one side, you have output on the other side. In between it is a deep neural network. So that is called end-to-end learning. So you don't do anything else, no feature engineering like PCA or ICA or whatever. Uh, most of that is not needed. The network learns as long as you have data for it. And you can also integrate multiple sources of knowledge into such end-to-end learning. So corpus data, predefined resources, and so on. So this is also an example of transfer learning. From machine learning perspective, we have pre-trained the model and then applied it to a new setting. So that is transfer learning. And we will be talking about some of these concepts in more detail later on. So there is a whole idea of word embeddings, which we'll also discuss in this course, meaning that you have rich representations for words or other linguistic units, which capture much more than simple, let's say, codes or even the sequence of characters. All right, so let me move to the next slide. So NLP takes input from multiple fields. So statistics and probability is used extensively in NLP. So machine learning and AI is also uh, used, and you can say NLP is a part of AI. So data structures and algorithms, of course, you are processing lots of data, so you need to have efficient models and algorithms. So linguistic is important. You need to understand what you're processing and how that language has been generated and what are its various characteristics. Though most of that comes from linguistics. And also a bit of psychology as well, because of usually language is human generated. So human generated language has several shades and nuances that uh, would be better understood if you have a better idea of psychology. And then of course, there might be other areas as well. So this is just a short list. From a technical perspective, of course, probability uh, and machine learning is the most common fields that go into NLP. Okay, any questions? So I have placed the slides for this course so far on LMS. So for those who have visited LMS, they might find it under resources. So these slides are available there. So I just want to spend 10-15 minutes on linguistics to just to familiarize you with some terms and terminologies, because we will be using some of these terms and terminologies throughout this course. Just a second. All right. So what is linguistic? I will have very quick definitions here. Uh, and this is primarily meant to give you the names and some brief definitions. And then if you need to read into more of this, you can always search the web or look up some linguistic book if you have one. But you can find most of these terms on the web as well. So linguistic is the study of language, of course, with respect to both its form, structure, meaning, syntax, and so on. So linguistic, if you study linguistic in the social sciences, is also studies various, you can say, drivers of language, like the social environment, history, culture, even religion in some contexts, and so on. So a linguist, of course, is a person who is knowledgeable in linguistics. So I'm pretty sure there are linguistic courses offered here at LUMS, but I know most of you might not have taken them, but you might have heard some of these terminologies elsewhere. So linguistic has various subfields. branches, you can say. So phonetics is the study of the physical characteristics of speech and sound. Uh, so phonology is basically how sound impacts meaning. So for example, you can pronounce live, live, and live as live. So different pronunciation, but these two pronunciations convey that they have different meanings. The spelling, of course, is the same, live. So live match or I live in Lahore. So phonology, more about how sounds influence meaning, and phonetics is about the physical characteristics of sound. So, and so for example, in phonetics, you're also trying to code sound in some computer form. And of course, both of these are more heavily used in speech processing. For those who are taking speech processing, they might discuss both of these branches in more detail. In this course, we just have brief mentions here. So morphology, the study of word forms and how those forms vary and how their variations impact their meaning. So word forms means that you all know words have different forms. So, so for example, I have a word quick. So that is one form. If I put a ly at the end quickly, so I've added a suffix at the end of quick. So now its meaning, uh, its part of speech, for example, has changed. So similarly, there are many such variations. Ing, for example, putting an ing at the end of, let's say, running, for example. So all of this study is morphology, the study of words and their forms and their variations and how those variations change their rules in running text. And we will discuss morphology on and off throughout this course because it is important in text processing. So syntax is, I think you know about syntax from other languages as well. So basically how you can combine characters and words to generate correct language. So for example, if you're using Java, how do you write correct Java? Meaning that how do you write the characters so that your compiler doesn't give you a syntax error? So that is syntax about the form and structure of language. So semantics is about meaning. So how is the meaning of words in a sentence and how those meanings combine to give some other meaning to the whole sentence. So all about meaning, semantics. So syntax, semantics, also we will be discussing these in more detail. So pragmatics is basically the study of world knowledge or context, which is beyond what is written in the text that you have, but how that context defines the meaning. So, for example, if I give you the word COVID and do not provide you with any context, COVID, you will say that this is an erroneous word, misspelling, whatever. But if you have the context in which we are living today, right now, so you will know that this is referring to a particular uh, pandemic of this time. So pragmatics is about world knowledge and how that world knowledge impact meaning. Pragmatics, in this course, we won't talk about it in detail. It's primarily used in discourse analysis, or discourse analysis is not discussed much in this course. Uh, so, but it's an important aspect. So for those who want to go deeper, this is something that they can look into. So discourse analysis, of course, I've written it as a separate branch. So this is study of written text. Uh, so for example, you can think of discourse analysis of writings of the early 1900s and the writing of the early 2000s. So trying to compare and contrast those writings. It could be in various dimensions, vocabulary, styles, topics, and so on. Questions? So linguistic has other subfields as well. These are related to, uh, you can say, the drivers of language. And sometimes these subfields are primarily focused on these drivers. So historical linguistic, cultural linguistic, psycholinguistics, and so on. Social linguistics. So from a human perspective, also, you have several, you can say, finer details, so neurolinguistics or cognitive linguistics, and so on, biolinguistics. So these are also, you can say, several subfields, but these are fields that we won't be talking about in more detail, but you should know about these subfields as well. Of course, we are primarily focusing on computational linguistics. So use of computers to solve tasks related to languages, human languages. So you might have heard the word grammar many times. You must have studied grammar at various stages in your career. Uh, so these are the rules that guide the correct writing of a language. And you can also say that grammar is the rules, and this basically defines or kind of fixes the syntax. Remember, we talked about syntax as a branch of uh, linguistics. So the primary focus in syntax is grammar. So, so composition basically means how you combine words to create meaningful sentences. So that is composition. And a sentence may be composed of various subcomponents, and there are various names for it. Two important names are clauses and phrases. So a clause is basically a segment that comprises of a subject and a verb, and it often can stand alone as a sentence, while a phrase cannot usually stand alone as a independent sentence. So for example, he is sitting. So this is a clause. You have a subject, he, sitting is a verb, uh, and so it's also an independent sentence. If you just write he is sitting, that is fine. But if you add after that on a couch, so on a couch, that's a phrase. On a couch itself won't convey a complete meaning. And of course, it doesn't have a subject there. So this is two, you can say, components or compositions of a sentence. There may be others as well. If you go into linguistics, there are tons of them. So just to give you an idea, they might be different subcomponents of a sentence. So as I mentioned before, syntax is basically primarily based on grammar, but of course, grammar, uh, which is about rules of writing, also have aspects of morphology and syntax and other aspects as well. So morphology, for example, how do you uh, change the word by just adding or subtracting some characters from it? So part of speech, we have already mentioned this word before, just quickly, POS tagging or part of speech. So these are categories of words that have similar properties and rows in a sentence. And commonly we think of these, we have these rows as nouns, verbs, adjectives, adverbs, conjunctions, disjunctions, conjunctions, and so on. So in general, there could be many, many parts of speech, but the popular parts of speeches are about 5 or 6. So pronouns are also part of speech and so on. So one task that we will be studying in this course is part of speech tagging. So given a sentence, I want to know whether a particular word is a noun, a verb, a pronoun, an adjective, adverb, and so on. So we want to tag the appropriate label to each word. So that is called part of speech tagging. And also part of speech would help you in other applications as well, because it gives you better understanding of the writings. You can find out, for example, if you want to find a named entity, like a name of a person. So name of a person would for sure be a noun. Similarly, we talked about a subject and object sometimes. Both of these are usually noun or noun references, pronouns. So lexicon is a word that is commonly used. So this in more traditional sense is simply a dictionary. So it's basically a collection of lexical units in a language. So in a dictionary, you have a list of various words, and with that list, you might be given some other information, but in the most basic sense, it just may just be a list. So a list is called a lexicon, and one entry in that list is a lexical unit, and that is sometimes also called a lexeme, Lexeme, lexeme. So lexical unit or lexeme, a entry in a lexicon. Of course, you may have heard of thesaurus, for example. So thesaurus also is a dictionary, but it has additional information about synonyms, antonyms, and other stuff, and definitions of meanings and examples for each word and so on. So we have also briefly talked about named entity. So this is basically an entity that specifies an entity of a specified type. So that's why we call named entity. So what would be the type? For example, the name of persons, name of locations, uh, for example, dates, times. So you can specify categories of words of entity. Usually all of these are nouns. Uh, and then we call them in general as a group as named entities. So organization is also an important named entity. So organization, company names, and so on. So named entity detection or recognition, NER, is basically the task of assigning these labels to each word in running text. So if I have a text like I work at LUMS, and my task is to identify locations, or sorry, organizations, so LUMS would be tagged as an organization, while the others would not be tagged. So we will be talking about translation as well in this course. So just to clarify, sometimes people have confusion, what is translation, what is transliteration. So translation is basically writing, uh, trying to convert one language to another language, but also in preserving the meaning. So we now have good translators available out there. You can go to Google Translation and translate a given paragraph or passage to another language. So that is translation. So transliteration is basically converting one language from one script to another script. And the typical example here in Pakistan is Urdu is written in the Persian Arabic script. Typically, that's the standard form, but we also write it in Latin script, English using English alphabet, which is typically called Roman Urdu. So they have different scripts. So if I'm given Urdu in the standard script and I want to convert it to Roman script and vice versa, that would be transliteration. And of course, there are other variations, back translations, and we'll talk about some of these later on. So parsing is a process of identifying. So it's a process of identifying various components of a sentence of running text. And so, for example, we talked about clauses and phrases. So you can use parsing to identify which is a clause, which is a phrase, and so on. Uh, so parsing is an important component in understanding language. And this was used quite popularly uh, in the olden days. Nowadays, its importance is less, but still we need to know what parsing is. Uh, there are two main ways of parsing: dependency parsing and constituency parsing. Uh, in this course, we may not go into details of parsing algorithms, but you will hear terminology parsing on and off, which basically means that given a sentence, I want to find the relevant components of that sentence. I want to parse it, segment it. Of course, parsing is also familiar to you from, let's say, uh, the formal languages like Java, Python, and C, and so on. All right, so any questions? All right. So let me start about text preprocessing or processing. So, so first of all, what exactly is text? So text basically is a sequence of characters, right? So it's a sequence of characters. Of course, if we have, if we are talking about language in the form that we write, for example, I've written this sentence, sequence of characters, S, E, Q, U, E, and C, E. So S is a alphabet, uh, followed by, after S, you have E and Q and so on. So this is a sequence. Of course, there's a space there as well, and so on. So, and this sequence of characters is usually written following some rules. And we said those rules can be all called grammar, uh, written, following rules. These rules, of course, can be violated in some situations. That's why NLP is hard. And so all of these rules collectively, you can call them grammar. And also, you can say when we have written text, it's basically representing the syntax or structure. Because if you don't follow proper syntax, then of course it might not be following the proper grammar of a particular language. So, so if I write a word, I study at LUMS. So there are various. Let me also write a full stop there. So there are various aspects to even the sequence of characters. So I is in uppercase, study S is in lowercase. There's a space there. LUMS is all in uppercase. It's also abbreviated, or no, it's not abbreviated. It's an acronym.
Your mic is on mute.
स्क्रीन विजिबल है किसी को?
नहीं, स्क्रीन भी विजिबल।
सर आपका माइक भी म्यूट हो गया है।
ओके, हाउ डू आई गेट म्यूटेड? मैं म्यूट किस तरह हो गया था? अच्छा, ठीक है. सो कैन यू हियर मी नाउ?
यस सर।
अच्छा, ठीक है. अच्छा, ठीक है. सो ओके, सो आई थिंक आई डोंट नो कहाँ तक मैं रुका था. So I've written I studied at LUM. So within this sentence, you notice that there are various variations. So the character set consists of lowercase, uppercase.
एक्सक्यूज मी सर, स्क्रीन भी शेयर नहीं हो रही।
जी,
स्क्रीन शेयर नहीं हो रही है।
अच्छा, स्क्रीन भी बंद हो गई. अच्छा, जस्ट ए सेकेंड, ये क्या हुआ, क्या था? डोंट नो.
शायद आप थोड़ी देर डिस्कनेक्टेड हो गए थे तो जब भी कट गया था।
अच्छा, डिस्कनेक्ट हुआ था मैं.
मे बी।
अच्छा, ओके, जस्ट गिव मी a second. Is now everything fine? नजर आ रहा है मेरी स्क्रीन भी और आवाज भी आ रही है?
यस सर।
अच्छा, रिकॉर्डिंग भी चल रही है?
यस सर।
ठीक है. All right. So the character set in formal languages comprise of lowercase, uppercase, punctuations, special characters. and so on. There might be others as well. In, let's say, formal writing, you might have about 60, 70 different characters that are used. But if you go into informal writing, and also if you go into multilingual analysis, you might have hundreds of different characters that are used, distinct characters that are used. Okay? And of course, as I said before, to have good writing, you would be following some rules of those languages. All right. So now let's, this is just a quick what textual representation is. We'll talk about representation in more detail throughout this course. This is just simple representation as characters, nothing else. So it's a sequence. If you change the sequence, the things would become wrong. So I study at LUMS. If I change the sequence, so study, LUMS, at, according to English, this is incorrect English. Of course, if you change the sequence of characters within the word, you might get misspelling. Okay? All right. So now let's talk about some basic text processing. And we will start very quickly with regular expressions. And I believe regular expressions आप लोगों ने कहीं और भी पढ़े होंगे. Can someone tell me कहाँ आपने पढ़े हैं या नहीं पढ़े?
ऑटोमेटा में पढ़े थे।
ऑटोमेटा में पढ़ा है, ठीक है. But automata, I think, is not a core course.
बैचलर्स में पढ़े थे मैंने।
जी?
बैचलर्स में पढ़े थे, पास्ट में वो कोर कोर्स था हमारा।
अच्छा, मैटलैब में भी पढ़े थे. इंटरेस्टिंग. ठीक है. अच्छा, ठीक है. ठीक है. So I'll quickly go over regular expression. Why are we studying regular expressions? We just mentioned that. So regular expression is basically, you can say it's a language. It's a language that defines a set of strings. So you can use some symbols, and the answer to that symbol given some text would be a set of strings that conform to that set of symbols. So in other words, used for matching. So you can define, for example, you know about wildcards, for example. You use this all the time in searches. जहाँ asterisk आप डाल देते हैं, for example, इसका मतलब है कि वो asterisk में कुछ भी match हो जाता है. So such language or such way of specifying a set of strings is called regular expression. So let's say if you want to search for any or all of these words, woodchuck, and you notice that they are written in different ways. So W कहीं capital है, कहीं S end पे आ रहा है, कहीं W capital नहीं है, कहीं C capital है. ठीक है? So how would you be able to specify this? Let's say if you want to do exact matching, you will have to write each of these characters exactly to get that particular set of string from your text. But if you wanted to retrieve all of them, you'll need to specify in a more generic way so that you can get all of them, because semantically they are the same thing. Okay? So regular expression especially is basically a language for specifying a set of strings. So just see. So if I say R is a regular expression, let's say, so the output of R would usually be a set of strings that matches to the specification of R. So it could be a set of string, let's say A, B, and C. And it could also be a null set, meaning that nothing matches that R. Okay? So for example, okay, let's go straight into that because I don't want to spend too much time here. Most of you know these things. So regular expression is basically available to you in many languages, already pre-coded. There might be slight difference in syntax and maybe of the semantics associated with that syntax in the particular language. Of course, here I'm talking about the language, formal language, regular expression. Okay? It's not human language. So let's start with the syntax and see how it can be used. And so we have a table here. So you can use the square brackets to specify multiple characters that can be considered as OR. So if you want to have woodchucks with a capital W or a small w, you can specify both capital W and small w within square brackets. So now this would match both woodchuck with a capital starting with a capital W as well as woodchuck starting with a lowercase w. So square brackets में आप लिख दें तो वो आपके पास और का functionality देता है. So similarly, there are some standard combinations. So if you want to match any digit, you can put 1, 2, 3, 4, 5, 6 and 0 up to 0 in square brackets. But इसका sometimes वो implementations में वो भी दिए होते हैं, ranges भी दिए होते हैं. You can write within square bracket 0-9. So all characters from 0 to 9. And similarly, it is also defined for alphabets as well, A-Z, lowercase or capital A-Z in uppercase. So this would match all characters that are in uppercase or all characters that are in lowercase as the case may be. All right. So you can specify character disjunctions through square brackets, and also you can specify multiple characters as long as they follow some ranges in your language using the dash symbol. So you can also have the negation character, which is usually the caret. So in this particular case, you have a caret, capital A dash Z. So what does this mean? This means that you don't want any character that's uppercase. A to Z uppercase में uppercase character हम आगे हम caret डालें. Caret is always written in front of the distinction. In front of the distinction, the square brackets. So what about this? So in this case, basically, you have the caret in front of S. So you don't want the letter capital S, but you can have the small letter S But if you want to, let's say, actually have caret as a character to be matched, then you have to use an escape sequence. So usually the escape sequence is a backslash. तो आप caret से पहले backslash डालेंगे, and that it not be considered as a special character, in which case it has the meaning of negation. It will then be matched literally as the caret. Usually the caret works only when you have the caret at the start of the within the disjunction or outside it. If it is within the sequence of character, then it's used just like any other character. It has a literal meaning. ठीक है? ठीक है? So this is basically using the negation, and you can also have disjunction. So you can also use the pipe operator, the vertical bar, to have disjunction between sequence of characters. So remember, the square brackets was disjunction among all the characters in that square bracket. But if you have multiple characters that you would like to have as disjunction, then you can use the pipe or the vertical bar operator. So यहाँ examples दी हुई, but let me just give a quick example here. Okay. So for example, usually the parentheses are used for grouping. They are not considered as a character. ठीक है? So I'll say, let's say if I want to match color and color with the UR, so this would match both COLOR and COLOUR. ठीक है? Now we are matching complete words here. So similarly, let's say कोई दो words आपने match करने, let's say any two words, let's say कोई भी कर लें आप, let's say AB इधर है and AC. So this would output AB or AC. So let's say if maybe I can give an example. For the first case, let's say so if I apply the first regular expression on this, color would be retrieved as a word, right? And let's say if the sentence continues, and she likes the green color. Now both of them would be returned, COLOR and COLOUR, and all the other words would not be returned. So the output for this would be both color and color. ठीक है? I think we are running out of time, although थोड़ा सही था, but I think maybe quickly next time हम यहीं से start करके इसको 10 मिनट में खत्म करते हैं. Any questions? Sure. So any questions?